All right, I'm going to do the first problem on the first worksheet, which was practice with kinematics problems and problems with reflections in it. Before I start, I'm just going to give a brief overview of what we talked about in class right before we did it. I pulled up a video on my computer of me tossing a tennis ball into the air and catching it, and we looked at the displacement versus time graph for that. So I've got a computer program that can generate displacement and time graph from a video, and a velocity time graph from a video, and an acceleration time graph from a video. What we see when you throw something up in the air and it comes back into your hand, there's a couple different things that are symmetric. The displacement versus time graph, I'll just start off by drawing a sketch of what that looks like. So that, if you have displacement and time, it's going to look like this. So the ball goes up and then it comes back down, and this is symmetric about this point. The velocity versus time graph will look like this. So velocity starts off positive and then it ends up negative. Okay, so at the beginning it's got a positive velocity because it's moving upwards, and then when it gets to the top of its arc, it's not moving at all, so its velocity is 0. And then at the end, it's going the same speed but in the opposite direction. So it's got a negative velocity that's the same value as the first one. Okay, so sometimes in physics you'll have a problem where it says you throw something up in the air and it comes back down, or something gets hit into the air and then it comes back down. For those types of problems, sometimes you'll have to use these symmetries to write down the things you know. All right, so I'll start off with number 1 on this worksheet here. This worksheet, this is the set of equations that I'll give you for the quiz and for any tests that includes this sort of stuff, so you'll always have the equations. You don't need to memorize those. Okay, so number 1 says I toss a tennis ball 2 meters straight upwards and then catch it. How long is it in the air? Okay, so what I know from throwing something up in the air and catching it is that the part of it where it's up in the air and falling back towards me is the exact same as the part of it where it's going up to its highest point. What that means is I could just find the time it takes for something to fall from, it says, 2 meters in the air back down to 0. If I find this time and double it, then I have the total time between when I throw it up in the air and when it comes back down. Again, if we plot this on a computer, it's exactly symmetric. So the ball goes up to 2 meters and it comes back down, and does that in time up to 2 meters down. But the time between when it goes from the top back down to 0 will be half the time for the total. At the top of its arc, so if I throw something just straight up into the air, we can see from this that the velocity equals 0 at the top, so that'll be helpful for starting this problem and talking about what we know. So what I'm going to do is I'm going to solve a problem for what happens if we start something at 2 meters in the air and it falls down to 0. How much time does that take? And then I'll double that time. So for doing that problem, I'll write out my columns here. Okay, so we'll start off with a picture. So we'll just say there's that thing. It's falling downwards. I'm going to make an axis. I'll say this is the ground, so that's 0. It's starting from 2 meters in the air, and its acceleration is 10 meters per second squared downwards. All right, so first I'll write out what I know, or I guess I can write what I'm trying to find. I'm trying to find time. What do I know? I know that the initial velocity is equal to 0. I know that because anytime I throw something up into the air, at its highest point, it's not moving at all. It comes to a stop for an instant, and then it starts falling back downwards. So when I throw it up, it's going fast, and it starts slowing down, slowing down, slowing down. It stops, and then it starts speeding up on the way down. Where v crosses the time axis, that's when v equals 0. That's also when we're starting our problem. So we're starting here. We're going to end our problem there. Okay. So the initial velocity is 0. Our initial position is 2 meters because it starts at 2 meters in the air. So initial position equals 2 meters. Our final position is equal to 0. Our acceleration, so our acceleration for anything that's in the air and unsupported is always 10 meters per second squared towards the ground. I'm going to call this my positive direction here. So anything moving that way or pointing that way is positive. Anything pointing that way is negative. So A is going to be negative 10 meters per second squared. And I think that's all that I know. All right. So now I've got to find an equation that ties these things together. All right, so I've got VI, XI, XF, A, and T. I'm looking for an equation. The last three have VF in it, so I'm not going to use any of the last three. I'll use the first one. So we're going to say X final is equal to X initial plus VIT plus 1/2 AT squared. I'll rewrite this substituting in the numbers, so I get 0 is equal to 2 plus 0 times t plus 1/2 -10 t squared. All right. 0 times t is just 0, so I'll rewrite this as 0 is equal to 2, and I'll just say plus 0, and then 1/2 times -10 is, that'd be plus -5 t squared. Okay, so I'm looking for t by itself, so this 0, we can just get rid of that. I want to move the 2 to the other side, so I'll subtract 2 from both sides. Get -2 is equal to -5 t squared. Then I've got a -5 times t squared, so to get rid of that, I'm going to divide by -5 on both sides. -2 divided by -5, 0.4. That's equal to t squared. So I want to get t by itself, so I'm going to take the square root. Take the square root of both sides. I get t is equal to, and I'll do the square root of 0.4. So 0.4 square root, we get 0.63 seconds is equal to t. That's the time it takes for something to fall from 2 meters back down to 0 meters. So that's the time right here, going from 2 meters back down to 0. If I want the total time for me throwing up the ball and then catching it, that's going to be double that time. So I'm going to double that. So our final answer is t is equal to this times 2, which gives me 1.26. And you can time that if you want, so just if you take anything and you throw it 2 meters up in the air, it should come back to your hand in 1.26 seconds. That's our final answer.